Welcome back, my dear children, to the part 2 of today's session. Here we are going to discuss about simple harmonic motion. Before going to simple harmonic motion, let us see what is meant by harmonic motion. The oscillation which can be expressed in terms of a harmonic function, that is a sine or a cosine function, is called harmonic oscillation. And a harmonic oscillation of constant amplitude and a single frequency under a restoring force whose magnitude is proportional to the displacement and acting towards the mean position or the equilibrium position is called simple harmonic motion. That is, a motion is said to be simple harmonic if the restoring force is proportional to the displacement and if it is directed towards the mean position. Simple harmonic motion is abbreviated as SHM. A simple harmonic motion is expressed as y is equivalent to a sine omega t or y is equivalent to a cos omega t. Here a is the amplitude or the maximum displacement from its mean position. So we had seen that SHM is a periodic motion in which a body moves to and fro about its mean position. The restoring force is proportional to the displacement and is directed towards the mean position. An oscillatory motion can be called as simple harmonic if the displacement x of the particle varies with time t according to the function x of t is equivalent to a cos omega t plus phi. Here x of t is the displacement as a function of time. A is the amplitude, which is defined as the magnitude of maximum displacement from the mean position. Omega t plus phi is called the phase angle, where omega is the angular frequency and phi is the phase constant. Now let us see some terms which are related to SHM. Time period is the time taken to complete one oscillation. Frequency is defined as the number of oscillations completed by the body in 1 second. Its notation is nu. And SI unit is hertz or second raised to minus 1. Frequency and time period are related through the expression frequency is equivalent to 1 by time period. Now let us see what is meant by angular frequency. The product of frequency with the factor 2 pi is called angular frequency. It is denoted by omega. Omega is equivalent to 2 pi nu, where nu is the frequency. SI unit of angular frequency is also hertz or second raised to minus 1. Displacement is a physical quantity which changes uniformly with time in a periodic motion. It is denoted by y. Amplitude is the maximum displacement from the mean position. It is denoted by A. Phase is a physical quantity which expresses the position and direction of motion of an oscillating particle. It is denoted by the symbol phi. Now we are going to see in the next module that simple harmonic motion is a projection of uniform circular motion on any diameter of a circle. So we had seen that SHM is periodic, in which displacement is a sinusoidal function of time. So if you are plotting a graph between displacement and time, we can conclude that displacement is a continuous function of time. Now let us see the difference in phase. We had already seen that phase is a quantity which determines the state of motion of a particle. Its value is omega t plus phi, which is dependent on time. The value of phase at time t equivalent to 0 is called the phase constant phi. When the motion of the particle starts, it goes to one extreme position in that interval of time, and the phase during that time is considered to be 0. Now let us see to the graphs shown in the slide. In the first graph, we are given two different curves which are of same amplitude. But the starting point of each of these waves is different. Or else we can see that waves marked by the points 3 and 4 are having a phase difference of pi by 4. That is, after an interval of pi by 4 radians, the second wave is starting. In the second graph, we can see two different waves which are of different amplitudes. But both are in the same phase. That is, both are reaching the maxima and minima in the same interval of time. So referring to the curves 1 and 2, we can see that these two are of different amplitudes, and one is having a greater amplitude compared to 2. We had seen that angular frequency refers to angular displacement per unit time. It can also be defined as rate of change of phase. Angular frequency is larger than frequency nu by a factor of 2 pi. Consider an oscillatory motion in which the displacement x of a particle is given by x of t is equivalent to a cos omega t plus phi. If you are taking the initial phase phi to be 0, then x of t is equivalent to a cos omega t. Since this function is periodic, x of t must be equivalent to x of t plus capital T, where capital T is the time period. Then a cos omega t must be equivalent to a cos omega into small t plus capital T. That is, omega into t plus t must be equivalent to omega t plus 2 pi for these two equations to be equal, or omega is equivalent to 2 pi by t, where capital T is the time period. Hope you might have understood about simple harmonic motion and the terms related to it. Thank you, dear students.